using IoT standards for push-based communication of hydrological data. And yeah, I'm working for the Wupperverband. I'm a software engineer there. And yeah, we are actually some part of the end users that want to use all the standards and all the software that you are developing and discussing about. So first is a small introduction into what the Wupperverband does. The Wupperverband is a water resource management association in North Rhine-Westphalia. So what you can see in the lower left corner, here's the Rhine River and Cologne. The Wupper is an influent of the Rhine River. What we do, we manage a catchment area of about 800 square kilometers. We have 14 reservoirs, water reservoirs, for also drinking water, but also just usage water. And we have manage 11 sewage plants. And in the area where we are acting and managing water, we have a precipitation of about 1400 millimeters per annum. Of course, not in the last years where we have especially dry years, but a precipitation of this kind is usual. And in this area, we serve about less than 1 million inhabitants with water. So some words on the current data flow, what we're doing now or in the past. So we're relying a lot of batch processing. What we do at our reservoirs, at our facilities, we of course do automatic measurements, where you have a photo at the left bottom and then the left up. We also have to do manual measurements regularly. So parts of the sensors every day, parts every 2 weeks, and also some measurements yearly, just to control the automatic measurements. The measurements are automatically taken, and brought into expert systems and databases where they are collected, and they are not lying in some kind of harmonized manner, but we have to translate them into a database where we have some kind of harmonized data, and which serves as the basis of the sensor web. So we're using components of the sensor web for more than 15 years now. We have implemented, or had in the past implemented, the SOS. Actually, the SOS is not used actively. We are actively using the Helgoland API, which is not standardized. And from the expert systems, we have some kind of batch processing workflows once a day or during the night, or like more than certain hour intervals. We process our measurement data by files and integrate them into the database. So for one of our reservoirs, for the Panzer reservoir, this connection has broken actually, so it was a bit complicated to fix this connection. So we have to think about another way to realize the data flow into the database. And this was the initial motivation to also look at these Internet of Things strategies, the push-based algorithms. And as we learned in the last sensor web conferences, that there is this thing called SensorThings API, which we wanted to have a look at anyway. So that was an ideal use case to have a look at the STA and integrate it into our IT infrastructure. So yeah, we've set up the SensorThings API just for the automatic measurements at the moment. We use an GSV2020 from Siemens Gateway, where we connect the sensors from the Panzertaschenbarre, where we run a Node-RED software on to visualize and also do some programmatic, visual programmatic styles of the data flows. Then we publish the data to the SensorThings API. So what we use at the moment is, it's twofold because we're evaluating both the 52 North implementation and also the Frost server from the Fraunhofer. And we're communicating the data via WebSocket MQTT over some kind of observation bus that is opened by those STA implementations and publish it into a database. From the database, and the data is then automatically processed to the expert system, so that the expert system user interface can, of course, also access the data, but from this small piece of SensorThings database, we also can access the data via the REST API and also by the MQTT API. From this SDA, it's a small step to integrate the data to the 52 North SWE schema, the Helgoland source database, and then from there we can again publish it via the SOS, the Helgoland API, and of course this SDA endpoint now is part of our SensorWeb infrastructure. Some words about Node-RED. Node-RED as a practical hint. So it's an open source product. It's some kind of low-code programming based on Node.js and JavaScript. For event-driven applications. It's well documented. It's a large community, lots of plugins. For example, the MQTT WebSocket plugin comes from the scratch with the default installation, and this is what it actually looks like. So you need minor programming skills to build a workflow. The workflow in our case comes from the left to the right, where we connect to the S7 gateway, and then actually process the data a bit, make some debugging and some logging mechanisms, and then split all the data up and publish it to the SensorThings API. The visualization is done with our TaMiS dashboard. The TaMiS dashboard relies on the Helgoland Toolbox. The Helgoland Toolbox provides us the interface for communicating with the Helgoland API, but now also with the STA API, and with this push-based processing of the data, we are now getting more real-timiness. So before, of course, there were latencies of the data of a day or some hours, and now we are getting the data within minutes, which is far enough now for our use cases. And now we can do proper eventing on these things and so on. So for those who want to use this SensorThings API, so we are actually just using the sensing profile. A nice documentation is at developer sensor app.com. We have found out that the query options are very nice and helpful, and that they are actually standardized. So we are making excessive use of it. For example, expand, select, order by count. Data streams with some metadata. So we were looking for requests that were similar to the Helgoland API requests, for example, that endpoint Helgoland API /time series. And yeah, we came up with this. So this works with some kind of query options, filter options, where we expand things like the observed property, the thing, sense observations. We got the last observation with phenomenon time and a detailed feature of interest. And the result, phenomenon time, exactly here where we selected it. So to sum up this, for us, the SensorThings API provides two fit-for-purpose APIs within the sensing profile, one for the push-based access and data communication, and one for the pull-based access and data communication. For us, it was very easy to adopt, and it's very lightweight. It's based on de facto standards or even standards of the internet communication, MQTT protocol. And what was also very important for us and made us thought about the lightweightness of this approach is that the data set and data stream metadata are managed in the database itself, and you don't need to some kind of send somehow the data set and data stream metadata from a sensor. Now our next steps are that it allows now for service-based data processing in the sensor web. For example, we are now making some steps with frameworks like Apache Kafka, or allows for service-based data science with Apache Spark. Jupyter Notebooks is really nice for this, and we can not just access but also push back the data science results. And it's pretty much an OGC standard, as practical as the well used and widely used WMS for the sensor web at last. So it really makes fun working with this SensorThings API. The next steps for us, because there are also next steps, we want to evaluate how we can submit manual measures. So we're now communicating from the things to the SensorThings API. Maybe it's not meant to also communicate manual measures, but we'll actually do it because it provides us a nice interface, not via MQTT in this case, but more from the from the REST side. We will communicate, or at least evaluate, how to communicate manual measures to the database through the SensorThings API. We have to evaluate, because the Panzertaschenberre is one of our smallest facilities, how we can scale the communication workflow in our IT infrastructure, because we want to actually roll out this for all Wupperverband facilities, so not only for the reservoirs, but also for the sewage plants. And evaluation of performance of both the MQTT protocol and the REST protocol, for example, also how it deals with those complex query options. Will it last long, or is it just a matter of milliseconds to return the data of a database that has millions of observations? And also the evaluation of integration with the standard from the Industry 4.0, the OPC UA, how we can retrieve data from servers that provide us the OPC UA standard. So, and the next bunch of feature requests for the discussion during the next 2 days. Actually, we wish an integration with the current ZOS-DB schema, so that the SDA and the Helgoland API can be served from the same DB schema based. For instance, the harmonization of primary keys. Better JavaScript support. The current support of the Helgoland Toolbox is pretty much rudimentary and does handle data stream as second-class citizens. So yeah, data streams from the SDA as first-class citizens would be very nice. Then what would also be nice is some kind of data stream and dataset metadata editor. We can edit the data with SQL. We can edit the data via post requests to the SDA. But yeah, some kind of graphical user interface would be very, very nice. And please, no SensorML based thing, but the SDA provides us with with classes for phenomena and features of interest. And yeah, that would be a very nice thing to have. And the last point, as we want to submit also manual measures, we want to have some kind of role-based editing of data stream clusters. That means that we have a bunch of SensorThings API IDs, and those IDs are only editable to a certain role, and then we have another bunch of role-based, another bunch of SDA IDs, and these would be edited from another bunch of from another role. To have this kind of authorization stuff in there. Yeah, thanks very much.